Hi, my name is Benedetto Marelli. I'm the Paul M. Cook Career Development Professor at MIT. I'm working in the Civil Environmental Engineering department, and my work is about feeding 9 billion people with silk fibrin. My training is in biomedical engineering, where I have both a Bachelor of Engineering and a Master of Science. My work has always been about structural biopolymers, so materials that we can get from nature and how we can reinvent them and re-engineering them. And at the beginning, the focus has been about how we can use these materials to engineer parts of our body, so how we can engineer tissues, typically, and how we can regenerate tissues. I have a PhD in material science and engineering from McGill University, where I studied bone mineralization. And then eventually I got really caught up with the work with silk and structural biopolymers in terms of how we can use them as a new technological material. So I did a postdoc at Tufts University, and then finally I arrived here at MIT 3 years ago. So structural biopolymers are the building block of nature. So we are made by structural biopolymers, right? So we're made by keratin in our hair and in our nails, by collagen, by laminin, elastin. Some of those polymers is very interesting because it's been engineered by nature to perform outside the body. This is the case, for example, of keratin, of silk. And what we like to do, we like to take these materials from raw materials that we find in nature, like, for example, silk cocoons, and then we want to re-engineer them and to use these materials as a building block to engineer advanced materials that can be used at what is called the biotic-abiotic interface. So materials that can only perform as technical materials, but can also bridge the interface with the biotic world, so with the living materials, basically. So my work has been primarily concentrated on collagen and silk, but eventually, as I moved out from the application in the body, I concentrated more on silk rather than collagen, because collagen is very well suited to work inside the body, but not outside the body. And my work with silk has been primarily on the engineering of optoelectronics materials that can be either implanted on the body or can be left in the environment, but also on study how the materials assemble in the nanoscale and how we can control the assembly of the materials in order to make advanced materials.